Are we going to trick or treat with them?
Can the behavior of typically developing children be more fully understood by studying the brain? How are cognitive skills influenced by brain development? And what is the relationship between the brain and behavior during adolescence? Neuroscientist Elizabeth Sowell compares behavioral changes with the changes in the shape, size, and structure of the brain. She uses a brain imaging technique called magnetic resonance imaging, or MRI.
Okay, so just keep going. You've got another 23 seconds, it looks like. It's been revolutionary because it allows us to look at the brain in living children. It's not harmful. It's what we call non-invasive. It means we can do these studies on children who are developing perfectly normally without harming them.
Prior to the use of MRI, many scientists believed that brain changes were largely complete after the extensive growth of brain connections during infancy and early childhood.
And there's not a lot going on during the childhood and adolescent years.
But that's not the case.
What we're seeing during childhood and adolescence is actually a loss of gray matter that occurs starting at about age 7, 8, 9. And the gray matter is the part of the brain around the surface, and it's really where the thinking happens. It's where the cell bodies are and the synapses that connect different regions of the brain. And we're seeing a loss in gray matter that occurs throughout the childhood and adolescent years. Oh, this loss isn't necessarily a bad thing. What's happening is that the gray matter is pruning itself. It's becoming a more fine-tuned system.
To understand this, we can first look at a 3D image of the brain that is based upon MRI scans. This is prior to the loss of gray matter.
This is an animation that's going to give us an idea of what parts of the brain are changing when. The color represents different regions of the brain. So in purple, here's the frontal lobe. In red is the parietal lobe, yellow occipital, and blue temporal.
Areas in the back of the brain, like the occipital lobe, lose gray matter first during early childhood. In this next image, it's important to note that the colors now represent where gray matter is being lost.
Now, these are areas in the brain shown in color here that are changing between childhood and adolescence. You can see there are changes in the frontal lobe and the parietal lobe. These are regions where we are losing gray matter.
And this loss accelerates into adulthood.
This is a map of changes that occur between adolescence and adulthood. You see there's a lot more regions here in purple. These are regions where there's an increase in the loss of gray matter that occurs between adolescence and adulthood.
But while the frontal lobes are losing gray matter, the brain is not changing much in size because there are gains in white matter. White matter insulates fibers that connect different regions in the brain.
So what happens when we insulate the fibers that connect different regions of the brain is they become more efficient.
And brain changes are reflected in cognitive changes.
We have studies which show that there's a correlation between the amount of gray matter in the frontal lobe and a child's ability to perform on a test of memory. So the children who have less gray matter actually perform better on the test than the children who have more gray matter.
The frontal lobes develop most dramatically during adolescence.
That's kind of important because the frontal lobes are the part of the brain that are sort of the executive centers. They're the control center. They're in charge of planning, organizing, controlling emotion.
And for many adolescents, it's a stressful time.
Prior to these brain imaging studies, people would have attributed the more negative aspects of adolescent behavior to hormones. But these new imaging studies have shown us that we should really be looking perhaps more closely at the brain as the target reason why these behaviors are occurring during adolescence.
Yet Sowell is cautious.
We haven't really done the studies to connect directly erratic behavior during adolescence and frontal lobe maturation, but those are questions that we're continuing to study.
Yet we shouldn't underestimate adolescents.
Adolescents, we should say, are fully capable of functioning very highly in society. And I think that what happens is the environment sort of has to become the frontal lobe for the adolescent until their frontal lobe is developed. So strong parental support, strong peer groups, good educational systems kind of act as the external frontal lobes until adolescents are really capable of functioning independently on their own. And that may require frontal lobe development.
And future research will attempt to make these brain behavior connections more explicit.
As scientists, we're continuing to look at, to try to measure relationships between changing behavior and changes in brain structure. They're difficult questions to answer, but we're highly interested.